Okay, Demetria. It's kind of late in the game, but I'm going to try. I teach until 10 p.m. on Tuesdays, Thursdays, straight through from 4 to 10. So it was late when I got home. But I'm going to do what I can to help you out here. So here's an equation. That's what I'm going to start with. You asked for balance and equation, molar mass, empirical formula. So here's your one for balance and equation. Your goal is, here's a balance and equation one right here. This says CH3OH plus O2. Let's just talk about what kind of reaction this is first. If you have a hydrocarbon with nothing but hydrogens right here and carbons, and then this has an alcohol on it as well, plus O2, you immediately need to know what kind of reaction that this is. That this is a combustion. That's one of the things that you also asked about, types of reactions. This is a combustion. This oxygen right here, this O2, makes it a combustion, and the fact that it's also got this C's and H's. So if that's all you have is C's and H's and O's, and then you have plus O2, it is a combustion. And so immediately you know, oh, okay, I know what the products are here. It's CO2 and water. Now, I need to balance this. How do you go about balancing it? Well, I always put little lines in front here so that I am not tempted to try to change any formulas, because once my formulas are written, I cannot change them. So I balance by putting coefficients in front. Okay? And you have to think about it, Demetria, as if you're going to the store. I don't know if you're a baker. I bake all the time. So when I think about this, I'm thinking about if I were to bake brownies for a church, or if I were to bake something and I wanted to bake a double recipe, and the recipe calls for 2 eggs, and I need 4 eggs. And if the recipe calls for 2 cups of flour, or 2.5 cups of flour, well, I need to double that. I need 5. So that's how this works. Now, I can't just buy a piece of an egg. I have to buy a whole egg. And so that's where balancing comes in. And so when I balance, this is what I choose to do. I put a little squiggly line, and I explained all of this in the video. And I say, okay, this is what I need. These are my ingredients. Here's my carbon, here's my hydrogen, here's my oxygen. Those are the 3 things that are on this. There's carbon, there's hydrogen, and there's oxygen. Now count up how many of each of those things do I have on this side. How many total carbons do I have on the left? 1, and only 1. So I'm going to put a 1. And I'm going to add up how many carbons do I have. I have 3 there, plus I have 1 there. And again, it's like if you're baking. You might have to add flour now and then again later. So that's what you have, 3 carbons here, plus you got, hydrogens here. And you got another one here. You got it in 2 different spots. But that's okay. You still only have to go buy 4 at the store. 4. And what about oxygens? I've got 1 here, plus I've got 2 there. So I have a total of 3 that I need. Okay? And what about how many am I going to end up making? Well, I'm going to put my products, that's what I'm making, over here at the end. C's, H's, O's. That's what I'm making. Well, how many carbons am I going to end up with? 1. How many hydrogens am I going to end up with? 2. How many oxygens do I end up with over here? There's 2 plus 1 is 3. Okay? Well, this is not balanced. And I cannot start off with 2 eggs and end up with 1. Or in this case, I cannot start off with 4 hydrogens and end up with only 2. That's not okay. You can't do that in baking, and you can't do that in chemicals, because we can't destroy chemicals. We can't just poof, they're gone. There's only one creator, and it's not us. So we have to balance this. So what must we do to fix this? Well, we need to put a 2 in front, and we're going to make sure, I'm going to change the color of my pen. I can only put numbers in the blanks that I put in front right here. So I'm going to put a 2 here, and I'm going to, but that's in front of that whole thing. So it's like I'm going to the store, and I'm going to buy a bag of something, and it's got multiple things inside. So it's got the hydrogen and the oxygen inside there. So there you go. So that's changing my hydrogen and my oxygen. So now how many hydrogens do I have? I don't have 2 anymore. Now I have 4. How many oxygens do I have? I have 2 there, because see my arrow that I drew there? I had 1 there. Now 2 times 1 is 2. But I also have these 2 over here, so now I have 4. Okay? So now I have, my hydrogens are balanced, but my oxygens are not balanced. So how can I fix that? Well, I have oxygens on the left side as well, but I have them in 2 spots. What 2 spots do I have? Let me move this plus sign over just a little bit. I have them in 2 spots. I have oxygens with the C's, H's, and O's over here, but I also have oxygen right here that's all by itself. Well, if I can, I want to change this one right here, because if I change that one over there, that's going to mess things up. And I don't, if I can help it, I don't want to touch that one. But it doesn't look like I can help it. So I guess I'm going to have to. Because that's going to be an odd number. So I'm going to have to put me a 2 right there, and that's going to mess up everything again. So there we go. That's going to change my hydrogens also. And it's going to make this a 2. It's going to make my hydrogens, instead of being 4, now I'm going to double that and have 8 of them. And it's going to make me have how many oxygens? 2 plus 2 is 4. Okay? So, but that's messed up my carbons. Now, what am I going to do? This one's a hard one, Demetria. So, I'm going to have to put a 2 right here. It's going to change my hydrogens, my carbons and my oxygens. Now I have 2 here, and I also have how many oxygens? 2 times 2 is 4, plus I also have those 2 is 6. Okay? But I have 8, so I need to change this 2 that I have right here. That's why you need to do this with a pencil. And I'm going to put a 4 right here instead. So now I have 8 of these, and how many oxygens do I have? 4 times 1 is 4, plus 4 is 8. Is that correct? 4, there's 8 plus 4 is 12. So I have a total of 12. Let me make sure that's right. 4 times 1 is 4. And that's 4. Oh, no, I just have 8. I have 8. Do you see that, Demetria? 2 times 2 is 4 right there. This is 4 right here. And then 4 times 1 is 4 right here. 4 plus 4 is 8. That's where this 8 came from, right down here. Okay? Now, how many do I have? How many do I have on the left side? I have this 2 times that 1 is 2 right there. Plus I have this 2 right here. So how can I fix this, Demetria? I have this 2 right here, and I don't want to mess with this 2 if I can help it. So 2 plus what makes 8? I need to have 8 right here. I need 8. So what can I put in front of here so that I'll have 8? How many bags do I need to buy at the grocery store, if you will? Can you see with me that 3 times 2 makes 6, plus 2 more would make my 8. So 3 times 2 is 6, plus those 2 that I have over here with the CH3OH is going to make my 8. So now I have 8. Now I probably should have chosen an easier one, but I didn't. So this is the hardest one that you'll probably ever have to balance, one like this, because combustions are by far the hardest ones to balance. So if you can balance this one, Demetria, you can balance any of them. Okay? So that's exactly how you go about balancing it, and it's all about making every atom have the same number on both sides. Okay? And I'm going to use the same thing to do You also asked about molar mass. Molar mass is the easiest thing we're going to do, and I'm going to use the same things that we used before. This is methane, methanol, methyl alcohol, like what they use in airplanes. So let's find the molar mass of this. You're going to use this formula, and you're going to use your periodic table. On your periodic table, in each square of your periodic table, and you'll be given a periodic table by Mr. White when you go take your midterm. On your periodic table, it has for you the molar mass of each thing. It has the symbol I'm going to draw for you, like what you might see for this first one, carbon. It's got the element. I'm looking in the front of my book right now, and it's got a number 6 up at the top, and then it says the word carbon, and then it has this decimal number, 12.01 in my book. 12.01 if you'll look in the very front flap of your textbook. I did not write the word carbon because it'd be too much writing, and I didn't think you could. And then it has this number 6. This number 6 tells you how many protons is in carbon, and this number down here is its atomic mass. That's how much it weighs. All right? So you're going to use these numbers right here, this one right here, to find the molar mass. It tells you how much 1 mole of this compound weighs, because we don't have time to count out a mole. A mole is a lot, 6.02 times 10 to the 23rd. You don't have time to count that many out, but we do have time to weigh it. So it's easier to do that. So here's how you do it. We have 1 carbon in this compound, and each of those carbons has this molar mass. I got that from the chart. How many hydrogens do we have? We have 3 right here and 1 right here, so we have a total of 4. On your chart, if you'll look up that number on your chart, it's in your book, it says 1.008, but I'm going to round that off to 1.01. That's pretty common. And then you have oxygen. How many of those oxygens do we have in this compound? 1. And each one of those, if you look in on your chart, and that's in the front of your book, it says 16.00. You hear me flipping back and forth to the front of my book. That's what you're hearing in the background. Now you're going to say 1 times 12 is 12.01. 4 times 1.01 is 4.01. 1 times 16 is 16.00. And then you're going to add those all together. So that's a 2, that's a 0, 2 plus 4 is 6, plus 6 is 12, carry my 1, 1 plus 1 is 2, plus 1 is 3. So the molar mass of this is 32.02 grams per mole. Now I can use this as a conversion factor to actually work problems, because I know that for every 1 mole of this stuff that I have, this CH3OH, which is called methyl alcohol, I have 32.02 grams of it. And so you can use it as a conversion factor. So I'm going to do the exact next thing where it talks about, you asked about theoretical yield. Okay? So let's say that you're asked to make something, and I don't know where you stand on the whole church going thing, but that's important in my life, so that's what I'm going to use. Let's say you would never use methyl alcohol in church. That's for airplanes, but that's the one I started with, so that's the one I'm going to end with. All right? And it asks you for, let's talk about the theoretical yield. Let's pretend that you have 10.4 grams of methyl alcohol rather. Okay, and it asks you how much carbon dioxide that you can make. So this would be our given. This is our given then. And our unknown would be how much CO2 could we make? Grams of CO2. Well, our first conversion factor, you're going to switch back to that balanced equation that we spent all that time doing. And what do we care about? We care about 2 things. We care about the methyl alcohol, that's 2 CH3OHs, will make us 2 CO2. So I'm going to flip back over here, and I'm going to rewrite that balanced equation. It was 2 CH3OH plus 3 O2s goes to 2 CO2s plus 4 H2Os. Okay? Now, we did that just a few minutes ago on that other page. That's where I came from. But look at our given right here. We care about the methyl alcohol, the CH3OH, and our unknown, we care about the CO2. Those are all we care about here and here. That's all we're going to focus on. That's all you're going to focus on, Demetria. So our conversion factor here is going to be, for every 2 of those, 2 moles of our CH3OH, we can make 2 moles of CO2. All right? Now, we're going to ask ourselves those 2 questions, and in my video I asked you, you got to ask yourself, am I ready to solve this? Do I have a conversion factor with my given? Do I have grams of CH3OH? And that answer is no. I have moles of CH3OH, but I don't have grams. And that's where this molar mass comes into play, this right here. I know because I just showed you how to do that. For every 1 mole of CH3OH, that is 32 point whatever I just said, O2. Yeah. Grams of CH3OH. Okay? Now, am I ready to solve yet? And I have one more question to ask. Do I have grams of CO2? And that answer is no. I have moles of CO2 right here, but I don't have grams of CO2. Do I know how to go from grams to moles? Yes, Demetria, you do. Because now you can say for every 1 mole of CO2, I can find out how many grams of CO2. How do I do that? With molar mass. So you're going to come over here on some scratch paper somewhere, and you're going to find it. You're going to use your periodic table again. How many carbons are there in CO2? 1. Each one is 12.01. Get that from your periodic table. How many oxygens are there in CO2? There are 2, and each one is 16.00. That came from your chart. So this is 12.01, and this is 32. So that's a total of 44.01. So that goes in that blank right there. Okay? Now then, I finally have, and I've boxed this for you in your videos and circled it and done everything I can do. There's grams of CH3OH, and then here is grams of CO2, grams of CO2. That's so important. If you can answer those questions, then you are ready to go. Now I can solve, and I'm always going to solve by starting with that given. What I am finding for you, Demetria, is called the theoretical yield. This is the theoretical yield, which in my video again, I said theoretically, if nobody snitches any of your cookies, how many should you be able to bake with what you have? I'm probably going to have to go to a different page, so let me just try, not even try this. Well, let me just erase this. I hope you know how to do this and you got how to do that. So let me just stay on this same page. So I'm going to start with my given. That's what you always start with. That 10.4 grams of CH3OH. And now I'm going to let my units tell me what to do. If I want this gone, which I do, I have to use these conversion factors that I spent all that time working on and use them to help me get rid of that grams of CH3OH. It's on the top, so I'm going to put it on the bottom. So I'm going to put 32.02 grams. I'm going to put 1 mole on top. Now that grams of CH3OH is gone. Now I don't want moles in my answer. I'm going to cross this out. Oops, that's the wrong thing, Demetria. I'm going to cross this one out because I've used it. I used this one, so I'm going to cross it out. Okay? Now then, I've got this moles on top right here. That's not what I want. I want to get rid of it. So see this top conversion factor that I wrote first? That you always need to write first when you're doing theoretical yield and stuff? I'm going to write it now. 2 moles of CH3 goes on the bottom. And 2 moles CO2. And you saw where I got that. I got that from our balanced equation that we did. Now that and that cross out. And I'm left with moles of CO2, which is still not what I want. So I know I'm not quite finished. And I'm going to have to go down to the next line here. And moles of CO2 is on top, so I finished with this. So I'm going to use this last conversion factor, and I'm going to put that 1 mole of CO2 on the bottom. Notice where I'm getting that. I'm getting it from right here. That molar mass, that last molar mass, 44.01 grams. And then I'm going to cross it out. This mole of CO2 up top takes out that mole of CO2 on the bottom. And so I'm finally ready to solve. And now you're just going to put this in your calculator. You're hearing me get my calculator now. And I'm going to start at the very beginning. I'm going to start right here with this 10.4 grams. So I'm going to say 10.4 grams. I'm going to divide it by that 32. Well, let me just start again. 10.4. I come to this number right here, 1 on top. So I'm going to say times 1 divided by 32.02 times 2 divided by 2 times 44.01 divided by 1. Demetria, I never took my hand off the calculator. I never hit enter until the very, very end. Okay, so my final answer, I got 14.3 grams of CO2. So theoretically, that's how much CO2 I should be able to make. That's what I should be able to make. Okay? Now, when you're doing, that's your theoretical yield. That's called your theoretical yield. Now, what if I have to tell you in the problem how much you were actually able to make? That's called your actual yield. If you actually go in the lab or the kitchen and you make whatever it is you're trying to make, how much you actually end up making is your actual yield. You will have to be told that, okay? And then to find your percent yield, that's easy enough. Your percent yield is how much you were actually able to make divided by how much you said you should be able to make in your math. Okay? And let's pretend on this one that the math said we should be able to make, we just got that answer, 14.3 grams. That's how much we should have been able to make. Let's pretend that we actually were able to make 10.1 gram. That's how much we were actually able to make. So what would be our percent yield? Well, we'd say 10.1 divided by 14.3, and we would get, then we times that by 100 just to make it into a percent. So our percent yield would be 70.6%. That's our percent yield. That's how you find that. I hope that helps you. I hope you can get that. I'm going to try to send this to you on Blackboard via YouTube. If not, then I'm going to try to email this to you. I hope this helps you.